We have new topics, and the topic is average power in a capacitor. So we are going to find what will be the power loss in a capacitors if there is uh, if we take one complete cycle. So we know that in a capacitor, when an AC is connected with this capacitor, so suppose at some strength the potential difference across the capacitor is E naught sin omega t. We know that the current and voltage are in different phases, and current at that moment has this value E naught sin omega t plus 90, because current in the circuit is ahead of the voltage by an angle of pi by 2. The phase difference between this alternating EMF and current is 90 degree, pi by 2. This is the phase angle of this current, which is omega t, plus pi by 2 phase angles of the voltage is omega t. The difference between them is 90, because it means that the current is ahead of the voltage by an angle of pi by 2. So this is the phase difference between them. So if I going in the quarter cycle, this is our quarter cycle, first quarter cycle. In the first quarter cycle, our current is increasing from 0 to maximum value. So during this period, our capacitors going to charge. So this plate become positive and this plate become negative. So here, when the charge is coming in the plate, so there is a electric field between these two plates. So the source have do some work done against the electrostatic force against the charge stored in the capacitor plate. For continuously building of the charges on this plate, the sources have do some work done. That work done is stored in the field of the capacitor fields, electric fields, in the form of the electrostatic energy. And in the second quarter, this first quarter, suppose it is fully charged. In second quarter, the charge is again transferred to the source. This is our source. First half, the capacitor plate got the charge. The second half, when it discharged, the charge goes again to our source. Again in third cycle, we have the capacitor plate charging in opposite direction. Now the current going in this cycle. In first half cycle, current are in this direction, and second half current will be in this cycle, anti-clockwise directions. Our right hand side plate become positive, left hand side become negative. So during this process, the capacitor again got charged. So in the third quarters, when it fully charged, and fourth quarters, the charges is again transferred to the sources. We call this is discharging of this capacitor. So in this way, we again come the initial position. After the initial position, I will be at this position. So this cycle is going. So it means that in one complete cycle, there is no power loss in the capacitor. We also say that in one complete cycle, the work done in the capacitor, which is done by the AC source, will be 0. But in a quarter cycle, there would be some amount of the work done. This work done is stored as the potential energy between these two plates. Let us start. This is our theoretical portion. Let us start mathematically how to calculate the average power loss across the capacitors is equal to 0. We know that power has a formula dW upon dt, or simply we can say that work done divided by time. If I take one complete cycle, our time period will be t, and the power has the formula voltage into current. Our voltage has this value. Now put the value in naught sin omega t and multiplied with the current amplitude. Our current amplitude will be I naught sine of omega t plus pi by 2. We know that sine 90 plus theta will be cos theta. It has the value E naught sine omega t. E naught is the voltage amplitude, I naught is the current amplitude. Sine 90 plus theta, sine 90 plus theta will be cos omega t. Replacing, putting I naught before sine omega t, it becomes voltage amplitude, current amplitude, sine omega t into cos omega t. If I place 2 in the numerators and divide also by 2, twice E naught I naught sine omega t into cos omega t divided by 2. We know that 2 sine omega t cos omega t has the value of sine twice omega t. So therefore E naught I naught divided by 2 sine of twice omega t. Now if I place this value in equation number first, I have able to find the total work done. Therefore total work done is equal to power into dt, P into dt, and your average power in one cycle will be work done divided by T, 1 upon T, integration of this value P dt when time equal to 0 and when time become time period of one complete cycle. From here to here your time period will be T by 2 and next it will be T. So time taken in one revolution, one complete cycles of this current or AC voltage will be capital T. Now putting this value here, so 1 upon T, 0 to T, power has the value at the time of T, E naught I naught divided by 2, and it has the value sine of twice omega t into dt. We know the integration of sine to omega t is minus cos to omega t divided by twice omega. So now it's the value E naught I naught divided by 2, and its integration is minus cos 2 omega t divided by twice omega, and taken the limit from 0 to 1 time period of the oscillation. So now here 2t minus 2 omega is taken out. Inside it has the value omega t minus cos 0. Now average power comes out minus E naught I naught divided by minus 4 omega t inside of this cos omega t minus cos 0 degree. We already know that omega is equal to 2 pi divided by t. From here omega times t becomes 2 pi. So if I replace omega t with 2 pi, the average power becomes minus voltage amplitude, current amplitude divided by 4 omega t had the value 2 pi, and here 2 into omega t and become 4 pi minus cos 0 degree. Voltage amplitude, current amplitude 8 pi, inside of this plus 1 minus 1 has a value comes out 0. So now 0. So when there is only a capacitor in the AC circuits, the power loss, I would say average power in one oscillation will be 0. because it has a different segment had different amount of the work done. In first quarters the capacitor got charged, second quarter it got discharged, third quarter again charged but but in opposite direction fourth quarter again discharged. It means that in one oscillation of this current and voltage, so there is no charge in the capacitor. So we can say that if there is no charge in the plate of the capacitors, the power loss, the average powers of these capacitors becomes zero. Average power dissipated in the capacitor in one cycle. One cycle means one oscillations is zero.